Alright, today's lesson is going to focus on geometric sequences and series. So recall from our previous lesson that a geometric sequence or series, you multiply by a common ratio each time. Alright, so the first types of problems we're going to do are those when we have to find the rule, the nth term of the geometric sequence. So here's another formula to memorize, where a sub 1 is your first term, r is your ratio, and n is the number of terms, or the number of the term that you're trying to find. Alright, so let's look at a couple of different examples using this formula, same formula each time. Alright, so here we have the following. Alright, write a rule for the nth term of the sequence, 512, 128, 32, and 8. And then we want to find the 10th term. So what do we need? Alright, so remember our formula was a sub n is equal to the first term times the ratio to the n minus 1. This might remind you of something. What does this look like? Well, it's exponential, right? It looks like an exponential equation, where r is our base. Alright, so this is one of our simple, easier examples. So a sub 1, that's the first thing in our list, so 512. Now our ratio. Remember, we need to take a previous, a latter term over a previous one. So we can find the ratio by doing 128 over 512, 32 over 128, or let's keep it easy on ourselves and do 8 over 32. Alright, which reduces to 1/4. Alright, so now we just got to plug in our formula here. So we've got a sub n, our nth term, is equal to our first term times our ratio 1/4 to the n minus 1. Alright, now because this is raised to this power of n minus 1, we can't multiply that 512 in our 1/4. So that's our final answer. So you might find geometric a little bit easier to clean up. Alright, let's find the 10th term now. So we're going to go 512 times 1/4 to the 10 minus 1. Alright, and here again you can use your calculator, and do leave this as a fraction. So you should get 1 over 512. Alright, so that's the easier example. Let's step it up a notch. So now let's see what we've got. We've got one term of a geometric sequence. The third term is negative 18. The common ratio is 3. Notice here we don't have our first term, so that means we're going to have to find our first term. So we're going to use our formula. A sub n is equal to a1 times the ratio of ratio to n minus 1. Every time you use your formula, write it down. That kind of forces you to memorize it, okay? Because you're going to have to know these formulas for your quiz and for your test. Alright? Okay, so we're looking for my first term. My a sub n is negative 18 is equal to a1. My ratio, they told me, I'm sorry, I'm going back to the previous question, is 3, and my n is 3. Alright, let's solve for a1. So we got negative 18 is equal to, this is going to be a sub 1 times 3 squared. So negative 18 is equal to 9a sub 1. So my first term is equal to negative 2. Alright, so now your formula, or your rule. So first term times my ratio to the n minus 1. So there's your answer. And I didn't ask you to find another term, so we're done with that one. Alright, one more example using this formula. Write a rule for the nth term of the geometric sequence with the third term equal to 8 and the fifth term equal to 2. Okay, so now we don't have anything we need. We don't have a sub 1 and we don't have the ratio, so we're going to have to find both. Let's work on the ratio first. Let's think about what's happening here. I've got my third term, my fourth term, my fifth term. So I know my third term is 8 and my fifth term is 2. Okay? Alright, so let's figure out how to find the ratio. Remember, I know I'm going to be multiplying by the same ratio each time. So that means that r squared is going to equal to 2 over 8. Because in order to be able to get from 8 to 2, I'm going to have to multiply by r twice, which is r squared. Alright, let's just solve for r here. So first of all, r squared is equal to 1/4. Take the square root of 1/4. This is principal root. Means I don't want a plus or minus, I just want my 1/2. So that means my ratio is 1/2. Well, now that I have my ratio, I can go backwards and find my first term. Alright, so a sub n is equal to my first term times my ratio to the n minus 1. I'm looking for a sub 1. I'm find a1. Alright, I can use either one. I've got my third term of being 8 or my fifth term being 2. It doesn't matter which one you use. I'm going to use a sub 3 equals 8. So 8 is equal to my first term times the ratio that I found, 1/2 to 3 minus 1. Alright, let's just solve for a1. So 8 is equal to a sub 1, 1/2 squared. So 8 is equal to 1/4 a1. We're going to multiply by 4. So a sub 1 is equal to 32. So a sub 1 is 32. Alright, now I have the information that I need. So let's plug into our little formula. So the nth term is equal to the first term times my ratio to the n minus 1. There's my answer. Alright, so 3 examples of using the geometric rule. Alright, let's look at some sums now. Let's first look at the sum of how to find a finite geometric series. So here's another formula. Add this formula to your list. So a sub 1 is the first term, r is your ratio, and n is the number of terms. Notice that your ratio cannot equal 1. Why? Because if the ratio is equal to 1, you're going to get 0 in the denominator, and that's never allowed. Alright, how do you know if something is a finite geometric series? Look at here. It has I equals 1, starts at 1 and goes to 13. So that's going to make my n 13. Now if this thing had started at 0 and went to 13, my n would be 14. So just be careful where this thing starts, whether it starts at 1 or 0. Your ratio, or remember our formula for our rule was a sub 1 times my ratio to the n minus 1. So my ratio is going to be 4. And then my first term, looking at here this rule again, my first term is 3. You can also find the first term by putting in 1. 1 minus 1 is 0. 4 to the 0 power is 1 times 3 is 3. Alright, now we just got to plug into this formula. So I'm looking for the sum of the first 13 terms. So my first term is 3 times 1 minus my ratio, 4, to the n power, which is 13, all over 1 minus my ratio. Alright, here again, like I said, you're going to be able to use a calculator on this. So you're going to put that in your calculator, and you should be getting a huge number, 7,108,863 is our sum. Hopefully one day that'll be your salary. Okay, so there's an example of a finite. I only did one of those because I think they're pretty straightforward. There's really nothing they can throw at you on that one. Alright, let's finish up our formulas here. Last formula. This is the sum of an infinite geometric series. Alright, so the first term is a sub 1 and our ratio is r. Now notice we have a restriction here. The absolute value of our ratio has to be less than 1. If the absolute value of our ratio is greater than or equal to 1, the series has no sum. It's going to keep getting larger without bound, so it doesn't have any sum. Alright, so let's look at this example. We have the following series. They tell us it's geometric. So my first term, well this is easy. My first term is 1. What's your ratio? It's going to be negative 3/4 over 1, which is equal to negative 3/4. All right, before you blindly start plugging into that formula, let's check to see if we meet our condition or not. The absolute value of negative 3/4 is equal to positive 3/4, which is less than 1. So that means the sum does exist. So now we can use the formula. So the formula is a sub 1 over 1 minus the ratio. So let's plug and chug. Right, a sub 1 is 1 over 1 minus negative 3/4. So 1 over 1 plus 3/4. All right, so 1 over 1 plus 3/4 is 1 3/4. Let's change that to a mixed number. I'm sorry, an improper fraction. So 7/4. Flip and multiply, so that means my sum is 4/7. But here again, you've got to remember to check that ratio, because it's going to let you plug into the formula. You're just going to use a formula when you shouldn't. You didn't meet the restrictions on it, so you shouldn't be using the formula. All right, let's finish up with a couple of more examples. Look at the next one. All right, so here we have again. We have find the sum of the infinite geometric series. All right, what's my first term? If you recognize it's 4/15. All right, let's find the ratio. So we're going to go 4/9 over 4/15. All right, flip and multiply 4/9 times 15/4, which gives me 15/9. We can reduce it if you want to, so 5/3. All right, absolute value of 5/3 is still 5/3, but notice this is greater than 1. So this means the sum does not exist. Okay, because it's getting larger each time. The number's getting larger, so we're never going to approach a single value. Sort of like approaching our asymptote. Sort of like getting, like I said, I mentioned limits before. That's kind of the whole idea of limits here. So this thing is going to grow without bounds, so it doesn't have a limit. All right, and notation does not exist. This is acceptable notation in the math world. I mean, the sum doesn't exist. All right, one more example. This one just has different notation. So we're able to pick out the things in different notation here. So here again, I need my a sub 1, which in this case is 8. My common ratio is 1/5. All right, 1/5 is less than 1, so that means I can continue with use my formula. So a sub 1 over 1 minus the ratio. So I'm going to have 8 over 1 minus 1/5. Now we just got to do that math. So we have 8 over 4/5. Flip and multiply. So 8 times 5/4, which gives us 10. So my sum is 10. Okay, so there are some examples of the geometric ones. So we have to add 3 more formulas to your list. So that means a total of 6 formulas you need to memorize in this section. All right, please, if you have any questions, jot them down so you remember to ask them in class.